Okay, Assalamualaikum and good morning again.
Waalaikumsalam, Miss.
Yeah. Okay, so sekarang ni kita akan buat the first tutorial. Okay, the first tutorial basically it wants you to draw the, bukan draw, dia minta kita awak name the IUPAC nomenclature kan? Apa soalan ni dah? Okay, so what is the IUPAC name for the following compound? So basically saya dah keluarkan siap-siap dah kat sini. They gives you condensed structure. So if you look carefully at the condensed structure, ini yang saya buat semalam dengan dia orang. No. Tak nak lah, okay tak apalah. Okay, saya dah pemudahkan awak dah. So dekat mana yang ada parenthesis, okay, so you have this compound kan. So whenever you have parenthesis, they are basically the substituents. So dekat sini kita tengok the substituent at this carbon number berapa. Okay, so now awak kena bagi tahu saya. The numbering will start from right or left. If you look at these substituents present.
Right.
From the right. Okay, so from the right we have the first, second, third.
From right.
Yes, fourth,
Right.
fifth,
Kanan.
yes, sixth and seventh. So the parent chain gonna be, apa nama parent dia? Kalau 7?
Heptane.
Heptane, okay, heptane, okay. Kita ada heptane. Okay, and then what about the substituents? You have substituents on which carbon?
2 and 5.
2 and 5. So their name is the same or different?
2 and 3.
2 and 3?
2 and 5.
2 and 5. On carbon number 2, what is the name of our substituents?
Methyl.
Methyl. So they're going to start from M. Okay, kalau at carbon number 5, what is the name of our substituents? Ethyl. So when naming a compound, when naming a compound, how? Yes. When naming a compound, how are you going to arrange that in a single sentence?
Follow alphabet.
Tak dengar. Apa?
Follow alphabet.
Follow alphabet. So follow alphabet, who comes first? E or M?
E.
E. So how are you going to make this compound? Kita start dengan apa nama dia?
5 ethyl.
5. In between 5 and ethyl kita ada apa? Comma or hyphen? Itu bunyi apa?
Hyphen.
Saya punya ni ke?
E.
E. Sekejap. Okay. E. So 5. E. Memanglah E. Maksud saya in between 5 dengan ethyl kita ada apa?
Hyphen.
Comma or hyphen? Okay, hyphen. 5 ethyl. And then we have another substituents of 2 hyphen lagi methyl. Boleh tak kita tinggalkan space dekat diorang?
Tak boleh.
Tak boleh, so rapatkan dia.
2 methyl.
Yeah, so nama dia is 5 ethyl 2 methyl heptane. Okay, for the second structure now. This second structure, what is the longest carbon chain that you can see? So we have a number of carbon chain present. Can be either here 1, 2, 3, 4, 5, 6, or maybe it can be 1, 2, 3. So between 3 and 6, who's got the longest carbon chain?
6.
Siapa?
6.
Tak dengar awak. 6. So 6 now, what is the name of your parent and suffix? What is the name of your parent and suffix?
Cyclohexane.
Cyclohexane. Okay, so this cyclohexane as your parents and also your suffix. What about your substituents? When you have cyclic structure, how are you going to put the numbering? When you have cyclic structure, how are you going to put the numbering? If you have more than one substituents, do you need to put the numbering for the substituents?
Yes.
Yes. So how are you going to put the numbering now? Tu siapa punya ni? Terganggu lah, ada bunyi. Amanina. Dia macam bunyi tadi. Okay. Macam mana? Cepat, numbering. The numbering will start from Y to Y. Okay, now kita determine dulu siapa dia punya substituents. So up here, highlighted in pink, what is the name of your substituents?
Isopropyl.
Isopropyl. Okay, how do you get the name of this isopropyl? So you look at the total number of carbon present there. You have 1, 2, and 3. So that's why the name is propyl. Okay. Mana awak dapat perkataan iso? Because of the look of this ikan. Apa? Ekor ikan. Okay, so sebab tu kita dapat iso. If let's say we want to use IUPAC nomenclature, how are we going to name this branch alkyl group? Macam mana kita nak letak nama dia kalau branch alkyl group?
1-methyl ethyl.
1-methyl ethyl. So kita tengok dekat sini kita ada the parent carbon chain. So the numbering will start from here. 1, 2. So 1, 2 makes up the ethyl. Okay, so dekat carbon number 1 we have methyl. So that's why the name gonna be 1-methyl ethyl. Okay, itu adalah kalau IUPAC. So sekarang ni kita akan ambil yang iso lah. So this iso is part of the prefix. But are we going to consider I or P as part of our alphabetical order? Kalau nak tentukan nama, kita nak tengok I ke kita nak tengok P? I. So untuk kita tengok I. Okay, what about the other substituent? What is the name of the other substituents?
Methyl.
Methyl. Okay, so nama dia adalah methyl. So now you have M and also I. Okay, we know when naming a compound, we must use the alphabetical order. Means I comes before M. But then you need to put the numbering. Okay, the numbering now, kalau dalam cyclic structure, awak kena make sure dia punya locations tu gives the lowest possible combinations of numbers. Okay, kalau case ni kita ada dua substituents, awak maybe boleh start from this isopropyl 1, 2, 3 means you're gonna have the combinations of 1 and 3. If you start from this methyl, you're gonna have 1, 2, and 3 as well. Maksudnya 1 and 3. So bila dia punya possible combinations tu sama, awak kena prioritas ikut dia punya alphabet tu pula. Okay, so kita ada I. Jadi kita nak letak numbering dekat iso tu 1 or 3. 1 or 3 kalau iso. You want to use numbering using the green one or the blue one?
One.
Apa?
Green.
The green one. Okay, so the green one suggests the name gonna be? Tell me, cepat saya nak tulis.
Green.
Okay. Nama dia apa?
One hyphen.
Okay, 1 isopropyl. And then?
Hyphen 3 hyphen methyl cyclohexane.
Yes, 1 isopropyl hyphen 3 hyphen methyl cyclohexane. So this is the name of the second compound. Okay, the third one. Look for the longest carbon chain. What is the longest carbon chain present in this compound? Tell me the name already. Apa nama parent awak?
Cyclopentane.
Cyclopentane got 5 carbon in them. So this is going to be our parent 1, 2, 3, 4, and 5. So the name of our parent will be cyclopentane. Okay, now we have how many substituents altogether?
3.
Ada 3. So these three substituents, awak kena tentukan the numbering ikut dia punya turutan. Okay. Maksudnya awak tak boleh tengok, oh just because of the alphabet dia lagi tinggi, kita start pada dia. Tak. Awak tengok hujung ke hujung. So dia most likely to pusing from here to there or from here to there. Macam tu sahaja dia punya pusingan. Okay. So sekarang ni, kita letak dulu dia punya nama alkyl group. So the first one up here containing 2 carbons. What is the name of this alkyl group?
Ethyl.
So they'll start with E. And then what about the second one? We have 3 alkyl group in a cyclic structure.
Cyclopropyl.
Cyclopropyl means kita akan start with C. Okay, what about the other one? This is a branch or
Butane.
unbranched alkyl group. Branch or unbranched?
Branch.
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 Okay, now. So kita start dengan IUPAC nomenclature dulu. So how are we going to name this branch alkyl group according to IUPAC? So the numbering?
Butane.
Okay, sekejap. 1, 2 and 3 kan? Ni kalau ikut IUPAC dia. So we have the longest carbon chain of 3. Maksudnya
1-methyl propyl.
yelah, propyl lah kiranya. Propyl at carbon number 1, we have 1 methyl. So nama dia 1 methyl propyl. Okay, yang tu kalau kita guna IUPAC lah. Kalau kita guna prefix, kita check macam mana. So sekarang ni awak ada how many carbons in total? Ada berapa? 4 kan? Kalau
Yes.
4 nama dia apa? Butyl.
Butyl.
Okay, butyl. And then look at the carbon there. This carbon, okay, carbon yang mana yang saya tengah cakap ni? Sekejap. Okay, look at the first carbon here. How many carbon directly attached to it? Ada berapa banyak carbon attached to it? 2. So dia tak termasuk yang ni tak termasuk, yang parent chain tak termasuk. So bila kalau 2, maksudnya dia akan jadi secondary carbon kan?
2.
Yes. So kalau secondary carbon kita guna prefix apa? Kalau secondary carbon kita guna secondary lah kan, sec is it?
Sec.
Okay, so for this prefix sec, are we going to put hyphen or no hyphen just like iso? Untuk sec
Put
butyl.
hyphen.
Put hyphen sebab dia simply
Yes.
secondary. Yes, iso memang ada bentuk dia sendiri macam tu. So sec butyl ni
Ada
dia
hyphen.
yes, ada hyphen. So now kita dah tahu the name of our substituents. Now we want to put the numbering. So your numbering, kita akan tengok lowest combinations of number. If you look here, we have exactly the same combinations. It's either 1, 2 and 3 as well as 1, 2 and 3. So which rotations are we going to take? The one highlighted in green or the one highlighted in pink? Green or pink?
Pink.
Pink, okay. Pink, kenapa pink? Kenapa bukan green? Sebab ikut alphabet. Kalau sebab ikut alphabet, dekat yang kalau ikut pink, pink kita akan jumpa E kan? The first one. Kalau ikut green, kita akan jumpa B, is it? B. So you're supposed to follow the green one or the pink one?
Green.
The
green one.
The green one. So kita akan letak nama siapa dulu first? Kita letak nama siapa dulu? Nak start dengan siapa? Kalau dah tahu nak start pada green, lepas tu kita nak letak nama dekat dalam tu kena ikut alphabet. So nak tulis macam mana? Nak tulis macam mana?
1 sec butyl.
Okay. 1 sec butyl. 2 cyclopropyl. Lagi 3-ethyl
3-ethyl.
cyclopentane. So the name gonna be 1-set-butyl, 2-cyclopropyl, 3-ethyl cyclopentane. Okay. So habislah untuk IUPAC nomenclature, the first one. It gives you the structural formula. They wants you to write the IUPAC nomenclature. Moving on to the second questions. This time, they gives you apa dalam ni? Instead of giving structure, dia bagi apa? Nama kan?
Yeah.
Okay, so they gives you the name of this compound. Now they want you to draw the structural
Yes.
formula. Okay, now let's start.
Yeah.
How are you going to start drawing the structure? How are you going to start drawing the structure? Terus subsequence ke? Print dulu.
Cari longest carbon.
Okay, the longest carbon chain gonna be
Octane.
octane with how many carbons?
8.
8 carbons. So you have these 8 carbons. So these 8
Okay.
carbon, maksud kita ada 1, 2, yeah. 1, 2, 3, 4, 5, 6, 7. Okay, and then habis octane. And then kita nak buat apa? Kita nak letak numbering. Boleh tak kita start pada mana? Kiri ke kanan? Kalau dah ada octane.
Tak kisah mana-mana.
Okay, tak kisah. So let's say kita start pada kiri. So on your carbon number 2 and 4, we have dimethyl. Dimethyl got how many carbons on your alkyl group?
1.
Okay, dimethyl 2 and 4, saya tukar colour hijau. Kita ada at carbon number 4, 1 branch, and then carbon number 2, 1 branch. Okay, 2 and 4 lah. Okay, and then at carbon number 5, we have this isobutyl. So this isobutyl got how many carbons altogether? Isobutyl berapa carbons altogether? Ada 4 kan? Okay, ada 4. And then kita kena ada iso. Iso ni dia ada dekat hujung dia ada CH3. Okay, jadinya awak pun ambil lah carbon number 5, we have 1, 2, 3, 4. Okay, jadi tak kita punya isopropyl kita? Kita check. Wait, isobutyl, sorry. Okay, your isobutyl here comes from this 1, 2, 3 and 4 makes up the butyl. And the iso is the part yang kita nampak here. This is your iso. Bentuk macam ekor ikan. Right. Okay, boleh ke? Naming this 5 isobutyl to 4 dimethyl octane?
Boleh.
Okay. Next one. We have 1,1-diethyl 3-tert-butyl cyclopentane. Okay, this cyclopentane gonna be the parent chain. So your parent chain containing how many carbons in them?
5.
5 carbons. This is a cyclic or open chain structure?
Cyclic.
Cyclic structure. So kita ada 5. 1, 2, 3, 4 and 5. Okay. So kita dah ada cyclopentane. And then you have 1,1-diethyl 3-tert-butyl cyclopentane.
Cyclic.
Yeah, so awak punya numbering boleh je nak start pada mana-mana. So at carbon number 1 you have diethyl. So 1,1-diethyl at carbon number 1, let's say from the right, we have diethyl containing 2 carbons. 1, 2. This is 1 ethyl, another one is 1, 2. Okay, let's say this is the first carbon. And then at the third carbon, kalau kata kita buat third carbon kat sini sebab 2 pusing sini, we have third butyl. Third means apa? What does meant by tertiary? Maksudnya, the carbon got 3 alkyl group attached to it, not including the parent chain, but altogether they got 4 carbons. So this third butyl, dekat carbon number 3, kita ada 1, 2, 3, 4. Okay, this is your third butyl. We have a total of 4 carbon, 1, 2, 3, 4. And this carbon directly attached to the parent chain got 1, 2, and 3 alkyl group attached to it. That's why the name is third butyl. Okay, boleh ikut lagi?
Boleh, Miss.
Okay, next one. We have this 1,2,2 trimethyl propyl cyclohexane. So we're going to start with our parent chain first. We have cyclic structure containing 6 carbon. So we have this 1, 2, 3, 4, 5, 6. Okay, and then you look here, you have this parenthesis. Why do we have this parenthesis? Okay, so basically, in this parenthesis, we have our substituents. But on top of the substituent, we have another substituents attached to it. In other words, the branch alkyl group. How do we know this? We have this aisle and also this aisle. Okay, sebab tu dia bubuh parenthesis. Kalau dia macam set butyl satu dia je, tak ada masalah pun, tak ada letak pun tak apa. Yang ni sebab dia on top of that dia ada lagi. Kalau awak guna prefix tak perlulah. Yang ni sebab dalam dia ada dia lagi. Sebab tu kita letak parenthesis. Okay, so at carbon number, bukan carbon number 1 lah. Dia basically ada satu je dia punya substituents now. Tapi dalam tu yang kita ada numbering lain. So the longest carbon chain for this alkyl group ada berapa carbon?
3.
3. So kita ada propyl. So propyl here adalah 1, 2, 3. Okay, settle. And then at carbon number 1, 2 and 2 we have methyl, all of them 3. Jadi kita ada dekat sini 1, 2, 2. Macam tu. 1, 2, 2 trimethyl propyl cyclohexane. So this is your structure. Boleh kah?
Boleh.
Okay, let's proceed to the third questions involving physical properties of alkene. Okay, let's recall a bit about these physical properties regarding bonding points. How many factors that we have learned that gonna involve in terms of its bonding point? Ada berapa factors affecting? Ada? Ada berapa factors affecting? Kalau dari segi bonding point kita belajar hari tu?
4.
3. 4 letak mana? Factors affecting untuk bonding point dulu. Ada 3 Wak. Ada berapa?
3.
3. What is the first one? What is the first one?
Surface area.
Molecular size. Molecular size dulu. Surface area tu betul, tapi dia punya main thing adalah molecular size. Daripada molecular size baru tahu surface area besar ke tak. Tu maksud dia. Surface area semua benda kita cakap pasal surface area. Tapi the main factors that the molecular size, okay, molecular size ni kita nak check apa? Adakah between the same carbon or different number of carbons?
Different number.
Yes, different number of carbons. So whenever you have more carbons than the other one, even though they have branching or not, always go for the most number of carbon as the first top priorities. So when you have different number of carbon, you're going to talk about the molecular size. Okay, and then if you got comparable number of carbon, maksudnya number of carbon yang sama, kita akan tengok the second factor. What is our second factor?
Branching.
Okay, branching. Branching kita akan cakap bila awak ada same number of carbon on your compounds. When you have same number of compound, then you can talk about the branching. So somehow the branching will talk about surface area as well. Okay, and lastly, kita ada cycloalkane versus alkane
Straight.
only. Yes, in other words, kita nak cakap pasal planar structure lah. Okay, so awak akan ikut dia punya priorities ni. Tapi dia depends lah pada dia punya situations. Okay, now, you have the first case here, given to you nonane, pentane, heptane and decane. Okay. Which factor do you think we're gonna use to discuss this question? The molecular size,
One.
branching, or the cycloalkane though?
Molecular size.
Okay, molecular size. So first we need to identify how many carbons are in this compound. Nonine, how many carbons?
9.
9 carbons. What about pentane?
5.
5 carbon. What about heptane?
7.
7 carbon. What about the decane?
10.
10 carbon. Okay, so soalan minta tunjukkan, arrange dia according to increasing order. So you need to first answer the question. So you first have, bila kata increasing boiling point, kita akan tunjuk ke arah kanan. Yang paling kanan, yang paling tinggi ke paling rendah?
Paling tinggi.
Paling tinggi. Siapa boiling point paling tinggi dalam kes ni?
Decane.
Decane followed by
Nonane.
nonane followed by
Heptane.
followed by
Pentane.
pentane. Okay, good. Lepas dah susun ni, awak kena cerita apa yang awak buat sampai dapat this trend. Okay, so how are you going to start explaining about this trend? Usually kita start dengan apa dulu? Bagi tahu tentang satu structure yang paling tinggi kan, paling tinggi lah usually. Let's say kita nak cakap pasal decane dulu. How are you going to explain about this decane being the highest boiling point?
Decane has
Okay.
bigger molecular size.
Okay. Decane has the biggest, macam tu.
The biggest.
Okay. The biggest molecular size. Lagi?
Bigger molecular size has larger surface area.
Okay, sebelum kita cakap tu, baik kita cakap tu sebab diorang ni benda yang sama kan? Awak dah bercakap. Decane, kita bercakap perbezaan antara diorang dulu. Decane has the biggest molecular size. Hence, it has, sekejap saya ubah layar awak sikit. Instead of cakap biggest molecular size ni, bagi tahu dulu highest boiling point tu. Baru kita cakap due tu, okay? Decane has the highest boiling point due to biggest apa?
6. Molecular size.
Yes, molecular size. While, kita cakap terus yang hujung. While pentane
Smallest boiling point.
has the smallest, ataupun kita kata highest, kita guna lowest. Lowest boiling point due to smallest molecular size. Okay. Kita dah cerita pasal dua species. Okay. Kat sini awak boleh cerita dulu apa yang kita nak cakap pasal bigger surface area ke apa. Okay, lepas tu awak cakap having apa?
Biggest molecular size.
Having bigger molecular size
Has larger surface area.
means larger surface area. Lepas cakap surface area, kita nak cakap dia buat apa?
More van der Waals forces formed between molecules.
Yes, formed between molecules.
Thus, more energy needed to overcome the stronger
Yeah.
van der Waals
Van der Waals
forces.
forces formed between molecules, hence stronger van der Waals forces. Hence stronger Van der Waals forces require, okay, sambung ayat awak. More energy to break. Betul tak?
Yes.
Okay. Lepas tu dah habis dah cerita. Kan? Habis lah kan? Betul tak?
Betul.
Alright. So untuk heptane dengan nonin ni, kalau awak dah cerita high dengan lowest ni sebab diorang punya case sama, awak boleh just stop sampai sini. Basically awak dah cakap dah. Tapi kalau nak sambung pun boleh, awak sambung lagi sikit. Sebab kita nak sebut juga pasal heptane dengan nonin. Awak boleh kata yang awak boleh kata yang nonin has higher boiling point than heptane because the molecular size is bigger. Dia basically benda yang sama je. Tapi sebab dia trend, kita kena cerita pasal semua juga somehow. Jaranglah dia nak bagi sama je spesies, selalunya dia akan campur. Okay, so that's how you explain about increasing boiling point in terms of molecular size only. Kena ada highest, lowest, at least nampak the trend. Lepas tu bagi tahu explanations regarding kenapa awak cakap dia macam tu. Okay, boleh?
Okay.
Okay, next one. We have these combinations of pentane, 2-methyl-butane, 2,2-dimethyl-propane. Okay, so kita illustrate sikit. So this pentane, we have straight chain or branch group. Sebelum tu. Pentane, 2-methyl-butane and 2,2-dimethyl-propane. All of them got how many carbons?
5, 4, 3.
Okay, awak cakap ni 4 Okay, ni 4 carbon as the longest. Okay, this is the longest. But then, dia ada 2 methyl kan? Dia tambah lagi satu
Yes.
carbon. 2 dimethyl, dia tambah lagi satu carbon. Maksudnya, total of carbon dia sama tak?
Sama.
Okay, bila total of carbon sama, adakah kita nak cakap pasal molecular size?
Tak.
Tak, kita nak cakap tentang
Branching.
branching. Okay, good. So this is, the expression is kind of similar to the one yang kita have discussed in lecture last Tuesday. Okay, tak apa. So sekarang ni kita nak kena susun dulu. Who do you think gonna have the highest boiling point? Bila kita nampak in terms of branching macam ni kalau tak keluarkan structure pun. Siapa paling tinggi?
2,2-dimethylpropane.
2,2-dimethylpropane paling tinggi high boiling point?
Oh, no. Pentane.
Ya, pentane paling tinggi. Sekarang kita nak susun increasing boiling point. Okay. We have pentane and then pentane got higher boiling point, the highest lah. Followed by siapa? Yang ada satu branch ke dua branch?
Satu branch.
Satu branch. So we have 2-methyl-butane followed by
2,2-dimethylpropane.
2,2-dimethylpropane. Okay, now. Kita nampak, tak buat pula. Kita nampak sekarang ni, pentane, dia ada straight chain sahaja, is it? Pentane has straight chain only, is it?
Yeah.
Yeah, the 2,2-dimethylpropane dan juga 2-methyl-butane got branching, is it? Betul tak?
Yeah.
Okay, so sekarang ni
Yes.
awak boleh cerita, first cakap pasal pentane, lepas tu cerita pasal yang branching pula. So, kita start dengan apa dulu? Kita nak start dengan pentane kan? Pentane. Cepat. Pentane Awak? How are we going to start explaining this?
Is a straight chain.
Okay, pentane bagi tahu dulu. Has the highest boiling point due to tadi awak cakap apa?
Straight chain.
Yeah, due to straight chain. Kenapa straight chain point?
Straight chain.
That has the largest surface area, is it? Largest surface area compared
Yes.
to branched compounds. Lepas tu cerita siap-siap apa yang akan jadi. More van der Waals forces formed, hence more energy required to break the strong van der Waals forces. Van der Waals forces eja penuh ni saya guna short form. Okay, kita dah cerita pasal pentane, settle untuk pentane. What about the other two? Okay, nak cerita macam mana? Nak cerita macam mana?
2-methyl butane and 2,2-dimethyl has branch
Okay,
structure.
lagi. Why not kita cakap dulu pasal boiling point diorang, baru kita bagi dia punya explanation. Boleh tak macam tu?
Oh, boleh.
Okay. 2-methyl butane has higher or lower boiling point than the
2-methyl butane
okay. Has higher or lower?
Higher.
higher.
Has higher boiling point than 2,2-dimethyl
Diameter
propane. Has the propane. Okay. Due to less number of branch, is it?
Yes.
Less number of branch has more surface area. Ikutlah awak nak cakap siapa dulu, nak cakap yang paling kecil ke paling besar ke, has more surface area. Asalkan cakap benda yang sama lah. Small surface area. Dah, cukup lah macam tu, okay tak? Right.
Miss, nak tanya. Kita kena mention ke yang tiga-tiga tu ada same number of carbon?
Tak perlu. Selalunya kita akan fokus, bila trend kita fokus pada pada differences. Boleh je kalau awak nak buat statement tapi tak ada markah kat situ kalau untuk similarities. Mungkin awak nak buat mukadimah dia, for molecule with the same molecular weight, branching decreases surface area. Tapi tak ada markah pun kat situ. Selalunya dia akan tengok sebab awak dah emphasize. Dalam straight chain, kita ada, kalau straight chain memang larger surface area. Bila awak ada branch, surface area pun dia akan main peranan lah.
Okay, Miss.
Okay, asalkan awak mention benda tu dan benda tu sampai, tak ada masalah. Asalkan ada point tu. Okay, next one kita ada apa dalam kita punya tu? We have apa soalan ni? Kita ada pentane, right? We have pentane and then we have cyclopentane. Lagi kita ada 2-methylpentane dan juga 2,2-dimethylpentane. Now tell me, what kind of comparison that are we going to use in this compound given? What? Okay, the highest priority kita kena check apa dulu? Molecular size kan?
Yes.
Do they have the same number of carbons?
Yes.
Do they have the same number of
Yes.
carbons?
No.
No. Okay, pentane got berapa carbon?
5.
5 carbon. What about cyclopentane?
5 carbon.
5 carbon juga, tapi kali ini dia dalam cyclic structure. What about 2-methyl pentane?
6 carbon.
6 carbon, and then kita tahu longest chain is 5 plus 1 carbon. Saya tunjuk 1 carbon ni adalah branch lah supaya kita nampak dia punya gambar macam mana. 2,2-dimethyl pentane, we have how many carbons altogether?
7 carbon.
7 carbon. Okay, the first priorities goes to number of carbon. If you got more carbons in them, means they got the highest boiling point. Then only the branching only happen to same number of compound. Itu baru kita tengok. Okay, sekarang ni arrange the following compounds according to increasing boiling point trend. Siapa yang paling tinggi boiling point awak rasa? So dia punya strand macam ni. So sekarang kita nak cerita. Macam mana kita nak cerita?
2 dan
Okay, so this 2 dan methyl pentane, apa jadi kat dia? Boiling point dia macam mana? Paling tinggi ke paling rendah?
has the highest boiling point.
Highest
Okay.
boiling point.
Yeah, good. Has the highest boiling point. Point. Saya nak due to, buat ayat. Due to
Due to the biggest molecular size.
okay, due to biggest molecular size that have the largest surface area, is it?
Yes.
Largest surface area. Okay, ambil balik sini. Largest surface area.
Pasal 2 methyl pentane.
Okay, itu methyl pentane pula nak cakap macam mana? Tu methyl pentane nak cakap seorang-seorang dia ke nak kena ni juga yang lain?
Sorang-sorang.
Seorang-seorang juga. Kenapa kita tak compare dia dengan 5 dengan 6? Kan boleh compare. Kalau cakap seorang-seorang, awak nak cakap macam mana?
Sebab number of carbon dia lain.
Okay, tapi awak boleh cakap dia punya saiz lagi besar kan? Maksud saya, kan dia dalam trend kan? Betul tak? Dia dalam trend betul tak awak?
Oh, ya.
Bila dia dalam
Betul.
trend, kita kena cakap kat dia, kena berkait jugalah walaupun betul number of carbon tak
Betul.
sama. Jangan cakap pasal branching, cakaplah pasal saiz dia orang.
Betul.
So kita akan cakap 2-methyl pentane has higher or lower boiling point? Has higher or lower?
Higher.
Okay, higher boiling point than
And cyclopentane.
pentane. Boleh cakap juga and pentane due to 6 carbon that makes the size bigger. Cakap je lah. Maksudnya kita bagi tahu yang dia has higher boiling point. Tadi highest, sekarang ni higher. Okay, macam tu. Lepas tu habislah untuk diorang dua. Dan kita kena compare antara siapa pula?
Cyclopentane and pentane.
Yeah, cyclopentane and pentane, they got different explanations. Okay, cyclopentane and pentane. Who's got greater boiling point? Cyclopentane has higher
Boiling point than pentane.
higher boiling point than pentane due to planar structure kan? Planar structure that provide apa? Size ke surface area?
Yes.
Larger surface area.
Surface area.
Yeah, then straight chain. Okay. Habislah itu explanations dia. So bila dalam trend awak memang kena cerita sentuh. Dia macam sentuh dan berkait juga untuk membezakan dia orang. Dan emphasize lah pasal main dia adalah boiling point. So kat sini kita cakap pasal higher boiling point lagi. Masuk nampaklah dia trend kan. Okay, last but not least. Okay, soalan cakap explain why butane soluble in benzene but not in water. Okay, so first, bila cakap pasal solubility, you have two types of solvent. One is non-polar solvent, one is polar solvent. Now look at your butane. Your butane now, it is a polar or non-polar molecule.
Non-polar.
Okay, butane is a non-polar molecule. So by right, when you have non-polar molecule, what kind of intermolecular forces apa je yang boleh kita buat kalau dalam non-polar molecule?
Van der Waals.
Van der Waals forces sahaja. So, kalau Van der Waals forces, dia ada dua. Sama ada London forces between non-polar and non-polar ataupun kita ada dipole-dipole, polar dengan polar. Okay. So, jauhlah sekali daripada hydrogen bond, is it? So, how are you going to explain this? Butane is a non-polar molecule, bagi tahu dulu. Bila kita dah kata dia non-polar molecule, tengoklah awak punya solvent. Kita ada benzene. Benzene rupa dia macam ni je. Kita ada benzene ring kan? So this benzene got only carbon and hydrogen. Kalau water pula, kita ada O, H and H with lone pair on them. Okay, we know in order for you to form hydrogen bond, we need to meet the two criteria. The first one, you must have handphone. Do you still remember the priorities tu? You have handphone.
Yes.
So means you have OH ke, OF ke ataupun OF pula, sorry. HF ke ataupun HN. Okay, sekarang ni in water we have one. Tapi kalau kita tengok dekat butane, butane got only carbon and also hydrogen. Attached to it we have hydrogen. So the second requirement, they want the neighboring molecules got lone pair on them. Butane ada lone pair tak? Ada tak nampak butane punya lone pair? Tak ada. Sebab itulah dia tak boleh dissolve in water. So awak boleh cakap butane is a non-polar molecule. Okay, bagi tahu dulu. It is insoluble in water sebab dia tak boleh buat apa?
Cannot form hydrogen bond.
Yes, because it cannot form hydrogen bond. Cukup macam tu. Orang tak tanya dah apa kriteria hydrogen bond. Okay, settle. Lepas tu dah menjawab dah insoluble in water. Kita sambung. Well, it is soluble in benzene sebab apa? Kita tengok pula benzene dengan dia. Ada tak persamaan antara dia orang? This is your
Both
benzene.
non-polar.
Yes, benzene got CH. So dia orang ni basically ada boleh buat apa antara dia orang ni? Kalau ada CH ni, non-polar and non-polar
Van
dia
der
boleh buat.
Waals.
Yes, Van der Waals forces. So it is soluble in benzene because it can
Van der
It
Waals
can form
forces.
Van der Waals
Van
forces
der Waals
between them.
forces. Yes, between molecule, between benzene, pula, with benzene. With. Bukan molekul yang sama. With benzene. So that's how you explain regarding the solubility. Sikit sahaja. Tapi untuk cerita pasal solubility, awak kena beritahu dulu lah dia punya molekul tu jenis apa. Okay, so now kita akan masuk about these reactions of alkane. Okay, reactions of alkane, we got only two reactions. First one is combustion. Another one is free radical substitutions, is it? Combustions and free radical substitutions saja untuk reactions of alkane. Okay, so combustion ni selalunya just for your knowledge lah, dia tak ada pun reaction apa-apa nak kena buat, just kena tahu react dengan oxygen. But then the one yang always being asked about these alkane reactions is these free radical substitutions. Okay, so you're given this question. A mixture of propane and bromine is exposed to sunlight. Okay, is exposed to sunlight. Write the reactions equations to show the formations of monosubstituted product. Okay, bila sebut monosubstituted product, kita hanya akan gantikan satu sahaja bromine at a time. Itu maksud monosubstituted product. Itu satu benda sebab dia melibatkan alkane juga. Alkane ada non-polar bond. Okay, lepas tu kita tahu kita ada sunlight, means we have UV light in this in here. So kita kekalkan je lah sunlight. Okay, so now on top of that, bromine ni sangat selektif. Sebab tu dia emphasize ni monosubstituted product. Selain dia akan gantikan satu per satu. Kalau you react with bromine, bromine is highly selective. Okay, usually dia hanya akan go for major product. Kalau contoh chlorine, awak ada possibilities untuk dapat tempat lain juga. Tapi kalau kata bromine, memang dia fokus pada major product, even though there are possibilities to form minor product. So itulah maksud monosubstituted juga. So untuk write the equations, you must have your reactant, your reagent, nucleophile and your electrophile. So sekarang ni kita ada propane. Propane got how many carbons? Propane is an alkane with how many carbons?
3.
3. So we have 3 carbons. We have 1, 2, and 3. Okay, so 3. CH3, CH2, CH3. So this is your propane. And then dia kata a mixture, maksudnya kena react lah. Bromine. Bromine sekarang kita nak tulis macam mana? BR je ke BR2? Bromine. Bromine.
BR.
BR2.
BR sahaja ke BR2?
BR2.
BR2. Okay, and that is exposed to sunlight with the presence of sunlight. So kena tulis. Kalau dia kata UV, tulis UV. Kalau dia kata light, tulis light. Kalau dia kata HV, tulis HV. Kalau dia tulis sunlight, tulis je sunlight. Okay, jangan ubah. Walaupun awak hafal UV, tengok soalan juga. Kalau dia tak bagi apa-apa, ikutlah awak nak guna UV ke apa. Okay, right now. So, you need to provide the product to be formed. Okay, now, how are you going to determine product to be formed? Look at this reaction. We are going to involve substitution. Means you're gonna substitute one of the hydrogen. In order for you to know whether they are going to form a mixture of product or only one product, you must look at the possible bond to be broken. Okay, kita ada bond antara CH3 dengan CH2 ni. Kalau awak tengok H dekat sini, sama tak environment dia dengan H dekat sini? Sama atau lain? H highlighted in pink has the same environment as H highlighted in black or not?
No.
No, jadi dia ada possibility untuk masuk dekat salah satu hydrogen dekat sini kan? Sama ada pink atau black, betul tak?
Yeah.
So produk awak pun akan ada possibilities lah untuk dapat benda-benda tu. Jadi sekarang ni kita akan substitute one of the hydrogen jadi Br. Okay, so kita akan ada CH3, CH, kita ada kat sini CH3, means one of the bond hydrogen kita akan tukar dia jadi Br. Okay, lepas tu kita ada mixture of product kan. Okay, so kat sini kita ada satu lagi. Now we have CH3, CH2, CH2, Dekat sini kita ada BR. Okay, now look at these two products. Okay, who do you think gonna be the major product? Major product here means the carbon, the stability of your carbon radical tu nanti. Siapa yang lagi stabil awak tengok? Kita tengok ni, carbon ni nanti dia akan jadi carbon radical tau untuk terima BR. Tengok how many carbons directly attached to them.
Yang hitam lagi stabil.
Yang hitam lagi stabil, dia class of apa carbon dia?
Secondary.
Secondary. So kalau yang ni ada satu sahaja. So siapa akan jadi major product?
Yang warna
Yang
hitam.
hitam.
Yang hitam ni. So this gonna be
Secondary.
major product. This gonna be the minor product. Kena tentukan siapa major, siapa minor. Sebab soalan seterusnya dia akan tanya awak tentang mechanism. Bila nak buat mechanism, kita hanya akan buat satu saja mechanism. Kita buat yang untuk major product. Walaupun awak tengok dalam nota, ada yang ditunjuk banyak kali. Sebenarnya nanti kalau ada exam untuk major product sahaja, tak perlu buat untuk minor ataupun any other possible products. Okay, now you know already this gonna be your complete reactions, the general equation. Each and every time you are asked to do the mechanism, please first write the general equations like this. Okay, start dengan yang ni dulu baru boleh buat mechanism. Jangan terus buat start mechanism sebab ada markah untuk these reactions kalau dia tak bagi lagi. Okay, now state the type of reactions. Type of reactions involved in here is apa type of reactions kita? Antara 4, rearrangement, addition, substitution ataupun eliminations.
Substitution.
Okay, these substitutions they involve what kind of species as a intermediates? Nucleophile, electrophile.
Free radical substitution.
So we have free radical substitution. Okay, so this is the type of reactions for this reaction. Okay, next one. The questions ask you to illustrate the mechanism for the formations of product. Okay, so product tadi kita akan fokuskan untuk dapat this major product. You want to substitute Br into this carbon in the middle, the carbon number 2. Okay, how are you going to start doing this mechanism involving free radical substitutions? How many steps do we have?
Tiga.
Okay, we have 3 steps altogether. Only for free radical substitutions, you need to tell step 1 apa benda, nama dia. Step 2 apa benda, step 3 apa benda. Sebab untuk any other mechanism tak perlu emphasize step number 1 nama apa. Okay, as for the step number 1, kita ada nama dia apa? Apa nama step ni?
Initiation.
Initiation. So initiation is where you want to form a radical. So your radical will start guna apa? Kita nak guna your propane or your bromine?
Bromine.
Bromine. So bromine bromine is a polar or non-polar molecule at the moment. Bromine, polar bond or non-polar bond?
Non-polar.
Non-polar.
Non-polar bond.
Non-polar will undergo what kind of cleavage?
Half.
Half. Nama
Cleavage.
cleavage tu. Type of cleavage involved apa benda?
Homolytic cleavage.
Homolytic cleavage. They will break symmetrically with 1 unpaired electron each. So kita tunjuk guna half headed arrow. Make sure kita sentuh this bond. Okay. Once kita dah break them symmetrically, kita akan dapat 2 equal parts of Br radical. So this is our radical now. Radical is highly reactive species. Sebab apa? Sebab sekarang ni keliling dia instead of ada 8 ke apa, dia ada 7 tau, 7 saja. So this unpaired electron is highly reactive, dia takkan stay still. So then we go to the second step. Second step is called
Propagation.
propagations. You are going to propagate the radical form by inserting it to the propane that we're going to use. So now kita akan lukiskan kita punya propane. When doing mechanism, we usually show the bond to be broken. Maksudnya walaupun dia bagi awak nak guna skeletal structure ke ataupun condensed structure, untuk bond yang kita nak break, kita akan keluarkan bond dia untuk tunjuk the bond breaking. So we have this hydrogen in between these carbons, and then kita akan further react with the radical. So we have these Br radicals waiting for this hydrogen to be taken. Okay, and then kita akan dapat kat sini. So the carbon and hydrogen bond pun diorang adalah non-polar bond. Jadi apa yang dia akan buat, dia akan breaks juga symmetrically. Okay, yang ni pula dia akan ke sini contoh. Pelik pula. Macam tu. Pelik je, sekejap. Macam tu lah. Right, dia akan buat dengan siapa? This Br dia akan pergi ambil radical yang being formed from the hydrogen. Okay, so sekarang ni lepas kita buat benda ni, kita akan dapat apa? Kita akan dapat a new radical form, right? New radical now, they belongs to which radical? Hydrogen or carbon? New radical kita. Awak? Radical kita siapa sekarang?
Hydrogen.
Carbon lah. Hydrogen ni dia dah pecah, dia pergi gabung dengan Br. Sebab tu dapat Br HBr. Oh nak? Ni. Nampak tak? Bond between carbon and hydrogen in green ni, kita dah breaks dia. Bila breaks dapat one each. So sepatutnya carbon radical dengan hydrogen radical, right?
Yes.
Lepas tu kan Br kan, dia kan pergi ambil yang hydrogen punya. Kat sini, nampak?
Okay.
Sebab itulah kita akan dapat HBr. So during these propagation steps, you are going to form a new radical. So this is your new radical form. This is your new radical. Okay. New radical form. But then, boleh ke new radical yang kita baru buat ni, dia akan duduk senyap juga. Macam Br tadi. Br tadi tak duduk senyap kan, dia terus attack kan?
Yeah.
Sekarang kita ada new radical, dia pun akan bertindak. Dekat dalam steps yang sama, kali ni kita akan ambil balik this radical, bawa ke second sini. Dalam step number 2 ni ada dua benda. Okay, so dalam awak punya reagent nanti kita ada abundance of molecules. Jadi tadi walaupun Br dah potong, dia still akan buat reaction lagi. Maksudnya Br ni still present. So apa yang kita akan berlaku kat sini, repetitions will happen. So this Br will breaks again symmetrically, yang ni ke sini. Yang ini pula dia akan pair up dengan this carbon radical. Sebab dia tak buat apa-apa lagi. Jadi dia akan hasilkan apa? Bila radical of carbon dengan Br bergabung, dia akan dapatkan satu bond. Bond consists of 2 electrons comes from the carbon radical and Br radical. Hence, can we get a new bond in here? Boleh tak kita dapat new bond dekat sini? Dekat carbon tu? Boleh. So kita akan ada kat sini, kita masukkan Br. So what will happen to this Br yang dapat satu unpaired electron? Dia akan jadi apa?
Radical.
Dia akan jadi radical. So kena lukislah radical tu juga. Tulis balik radical. So basically dia jadi benda yang sama balik kan. Awak ada radical, nanti benda ni akan ulang balik, buat balik kat sini. Okay, jadi kita tak naklah tunjuk semua. Sampai bila nak tunjuk bagi habis benda tu. So kita akan proceed je dekat the step number 3. Okay, step number 3 is called
Termination.
Okay, step number 3 is called terminations. Okay, so these terminations reactions, kita akan ambil semua possible semua possible radicals untuk kita combine semula sebab kita tak nak any radicals left. Kalau ada radical, reactions takkan stop. So kita kena hapuskan radical tu dengan cara gabungkan dia balik. So kita akan ada 3 combinations. They're gonna be between bromine and also ni carbon. Kita pun ada bromine dengan bromine. Kita pun ada carbon dengan carbon. So ada 3 gabungan. Okay, jadi sekarang ni awak kena tunjuklah setiap satu. So ada 3 benda. Step number 1 ada 1 benda, step number 2 ada 2 benda, step number 3 ada 3 benda. So kita start Br radical to pair up with Br radical. Show the movement of electrons, once up, once down. Dia tak boleh macam ni, tak boleh macam ni, tak mau. Tak boleh, dia kena once up, once down. You will get a new bond between Br and Br. Okay, so dia akan jadi stable molecules balik lah. Okay, lepas tu kalau kita ada carbon. Kalau kita ada carbon macam yang ni tadi. Okay, yang carbon ni. Kita akan pair them up. Okay. Kalau nak senang, nak cantik sikit. Okay, saya tunjuk. Kita ada CH3, CH3. Lepas tu kita ada H radical. Last with C radical, CH3, CH3, H, is it? So sekarang ni diorang akan pair up. Satu atas, satu bawah. So kita akan dapat a new bond between them. So kita akan ada CH3, CH3, H. Kita akan dapat a new bond between them. Carbon, CH3, CH3 dengan H. Okay, this is the second combinations. And the final combinations kita ada CH3, CH3 dan juga H, this radical pair up facing with this Br radical. They're gonna form this new bond of CH3, CH3, H, Br. Okay ke? So ada 3 benda. Okay, reactions between an alkane with molecular formula C5H12 with chlorine in the presence of sunlight gives only product. Okay, kat sini dia cakap only product. Bila only product, hanya ada satu jenis produk sahaja yang kita boleh dapatkan. Okay, now dia tanya, suggest the structure of C5H12 and write the reactions equation. Mula kena suggest apa C5H12 kita. Lepas tu kena write the reaction equation. Dah 2 benda dia minta. Yang ketiga, dia minta mechanism for the formations of only product. Okay. So kita first kena keluarkan dulu. Awak dah belajar kan? Kalau kita ada molecular formula, lepas tu kita boleh dapatkan dia punya structural formula. Betul tak? Kita panggil apa benda tu? You are given structure molecular formula, you need to show the various structure. So kita panggil apa benda tu?
Expanded.
Bukan, yang tu structural formula. Sekarang ni kita ada C5H12. Okay, awak tahu awak ada C5H12. Macam tadilah, ni sekarang kan kita tengah cakap alkane. Alkane react dengan chlorine with the presence of sunlight. Nak dapatkan only one product. One product awak adalah C5H11Cl. Alkane awak sekarang C5H11. Okay. Adakah kita nak lukis benda ni, lepas tu terus masuk Cl macam tu? Boleh ke? Itu ke yang kita belajar? Asalnya C5H12. Soalan saya sekarang ni, awak ada C5H12. Awak nak dapatkan C5H11Cl tapi satu jenis produk sahaja yang dapat. Yang macam tadi, kita ada more than one product, is it?
Yes.
Okay, jadi sekarang ni awak tak tahu molekul awak ni apa. Kalau 5 karbon sekalipun, methat, prop, butane, dia tak semestinya pentane. Okay, Jadi selain pentane kita boleh buat benda apa lagi yang ada total 5 karbon. Selain yang benda tu boleh buat apa lagi untuk total 5 karbon. Jadi sekarang ni saya tanya, apa benda kita panggil benda tu?
Isomer.
Yes, isomer. So you have the C5H12, awak kena keluarkan isomers dia dulu. Kita baru nak cari apa structure ni yang boleh bagi satu produk je. Okay, so we're gonna first start with the longest carbon chain. The longest carbon chain got 5 carbons. 1, 2, 3, 4, and 5. Okay. If let's say since we have alkane, what kind of isomer can be formed? What kind of isomer can be formed?
Chain isomer.
Chain isomer. So from the longest carbon chain of 5, kita akan kurangkan dia jadi 4 kan? Satu lagi nak jadikan branch, is it?
Yes.
Okay, lepas tu boleh tak kita pendekkan dia lagi?
Boleh.
Boleh. So kita akan ada CH3, C. Lepas tu kita ada apa lagi? CH3. At this carbon number 2, we have CH3 and CH3. So they all got C5H12. Okay, now soalan cakap sekarang ni, these substitutions will gives you one product, only product. Bila one only product, awak kena tengok possibilities untuk dekat mana dia being substituted. Macam mana cara kita nak tahu? Kita kena tengok dia punya class of hydrogen dia kan, untuk kita dapatkan apa kan.
Yeah.
Okay, so sekarang awak tengok on your pentane, how many products do you think we can get from this pentane? Look at the class of hydrogens. How many of them altogether? Awak rasa?
2.
2, okay. 2 comes from the first one, kita ada dekat CH3 kan? Ni class of hydrogen dia apa? Primary, secondary or tertiary?
Primary.
Primary, so this is primary. Okay, kalau dapat pun primary lah kat sini. Lepas tu lagi satu kita ada
Secondary.
secondary. So any other CH2 pun secondary, any other CH3 pun primary. Jadi kita boleh ke dapat only one product from this pentane? Kalau kita buat substitution?
Tak.
Tak boleh. So tak bolehlah kita kata C5H12 kita adalah pentane. Okay, moving on to the next structure. So this structure you got one branch. So look at the environment of this hydrogen. You have H3, you have CH as well. Nak tukar kali. CH, you pun ada CH2, is it? So awak ada berapa possible product dekat sini?
3.
3. Yang ini adalah secondary. Yang ini adalah tertiary. Yang satu lagi ni adalah primary. Jadi boleh ke kita kata C5H12 kita adalah this 2-methyl butane? Sesuai tak kita cakap dia?
Tak.
Tak juga. Okay, tengok the last isomers yang awak ada. Look at this carbon and also carbon hydrogen. We want to substitute one hydrogen with only one Cl. Look at the environment of your hydrogen. You got only CH3 hydrogen with only one, yes, hydrogen attached to only one alkyl group je kan? Dan diorang ni semua sama, betul tak?
Betul.
Jadi boleh tak kita kata structure ni yang sesuai untuk dapatkan only one product? Because we have only one type of hydrogens here?
Boleh.
Boleh. So kita akan ambil structure ni lah. What is the name of this structure? Could you please tell me? How are you going to name this structure? Apa nama dia? What is the name of this compound?
2-dimethyl propane.
Tu kan ada dua. Ada dua nombor.
2-dimethyl propane.
2,2-dimethyl propane. Okay. Good. So sekarang ni kita buatlah dia punya reactions. Okay, reactions dia. Saya gerakkan sikit bagi besar. General reactions dia sepatutnya adalah we have these C1, 2, 3, H, silap. C, C. Okay, kita nak buat reaction kat sini, keluarkan dia. So H, here we have H, here we have H. Ini tak apa, CH3, CH3, CH3. Okay, so kita akan react with Cl2, Cl2 with the presence of sunlight. You're going to form one and only product of CH3, 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 CH2, kita ada Cl. Inilah awak punya general reaction. So bila soalan minta awak suggest structure dah betul kat sini. Yang first one tadi kat sini. Dah betul, ni pun dapat markah jugalah nanti sepatutnya. Okay, now kita nak buat mechanism. Okay, the last one dah nak habis dah. Okay, so your mechanism. So the mechanism will involve the yang kita buat tadi tu lah. Okay, so kita akan start dengan step number 1, the ionization, right? Step 1 is ionization. So these ionizations, okay, we have the Cl. Cl1 and Cl, we break them with the presence of UV. And then we're gonna get, kita akan dapat apa daripada this homolytic cleavage? Kita dapat apa, Wak?
Radical of Cl.
Yes, 2 radical of Cl lah. Okay, 2 radical of Cl. And then we proceed with the second step. What is the name of second step?
Propagation step.
Propagation step. So during propagation step, what will happen during the first step ni? Kita akan react siapa dengan siapa? Kita akan react siapa dengan siapa? Kita ada carbon kita tadi kan? CH3.
Radical.
Yes. CH3, CH3, this CH2, kita tunjuk H dia kat sini. Okay, awak akan, sebenarnya tak betul buat macam ni, awak kena tunjuk. Dia kena bond C dia. H, H, dan juga H. Okay, kat sini kita akan break the bond. Okay, this one goes to carbon, this one go to somewhere else to pair up with the Cl radical. Let's say kita ada Cl radical kita kat sini. So dia akan pair up satu atas, satu bawah. Okay, kat sini dia sepatutnya dapat apa? Alah, tak muat pula. Dia buat bawah ni. Okay, kat sini dia akan dapat product of a new radical CH3, CH3, CH3. We have this CH2. So the radical will be on the carbon here. And then what will happen to the Cl and H radical? They will form a bond between them, H and Cl. Okay, since we have formed a new radical in here, what are the new radical of this carbon? Okay, awak kena pair them up lah dengan, kena buat balik dengan Cl. So ambil balik this carbon radical. Yang ni tak ada sambung-sambung kan, memang kena buat baru. Jangan sambung kat sana. So kat sini kita akan further react with Cl dengan Cl yang asal tadi. Kita akan break them, ambil kat sini, yang ni pair up. Okay, we will get our monosubstituted product of CH3, 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 CH2. We have this Cl. Okay, kita ada di Cl plus with Cl radical. Okay, so this is for the second step. As for the third step, this third step is called
Termination.
termination. Semua senyap ni. Saya je ke yang belajar? Cuba beritahu saya nak buat apa. Termination nak buat apa?
Two radical of chlorine react.
Okay, two radical of chlorine akan react by using the half-headed arrow, once up and once down. Okay, then we'll get this Cl2 bond. Okay, siap. Lepas tu kita ada radical of
Carbon.
carbon yang tadi tu. So kita ada CH3, 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 CH2. Okay, saya copy balik. Kita akan further react dia. Kita ada di CH2 dengan CH3. CH3, CH2. So we have this radical. Make sure to put plus in between them. And then we have these to pair up. Lastly, you will form a new bond between them. C, C. Okay, CH3, 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 CH3. Okay, so kita ada bond between them. Ni dengan ini. Okay, lastly kita ada this radical. Okay, lepas tu dia akan pair up dengan siapa? Dia akan pair up with chlorine radical. So this chlorine radical will take up this carbon radical to form our monosubstituted product. Just now kita ada distinct. Copy je balik. Right. Okay. Itu sahajalah untuk hari ni punya tutorial. So thank you everyone. Okay, bye. Assalamualaikum.